Hello guys, so today I'll be solving today's LeetCode problem. So today's problem is count the number of special characters 2. So the problem states that we have been given a string word. A letter C is called special if it appears both in lowercase and uppercase in word, and every lowercase occurrence of C appears before the first occurrence of C. First uppercase occurrence of C. Okay, and then the number of special letters in the word. So the problem is pretty simple. So if I take this example, okay, so we have been given A, B, so 3 A's, B, C, and BC. Okay, so what I need to do is I need to count the special characters. Okay, now the special character definition is so it has to occur in smaller case as well as in uppercase. Okay, and all the smaller case should appear before the first uppercase. Okay, so if I take this example, okay, so for A, okay, I can see A is from the first index. Okay, from the first index to the one index I can only see A. Okay, then the uppercase A is appearing here. Okay, so A is a special character. Okay, because all the small cases are appearing before the first uppercase. Okay, and you can see like there are no A's here. Cool. Then I have B here. Okay, now B is appearing here. Okay, and before the first occurrence of the capital B, okay, I cannot see any other occurrences of smaller case b. Okay, so yep, B is also a special character. Now for C, okay, so small case C is here. Okay, uppercase C is here. Okay, and I can see like there are no small c appearing before the big C. Okay, so C is also a special character. Cool. So yep, so ABC answer is 3. Cool. Now let's check out this guy. Okay, or let's say check out something of our own. Okay, so let's say I have been given capital A and A. Okay, so from this example we will be able to see like how to solve this problem efficiently. Okay, so if I check for only A here, okay, small case A, so I can see my small case A is starting from this index 0, 1, 2, 3, 4, 5. Okay, and the last occurrence is happening at 5. Okay, so for A it's from ranging from 0 to 5. Okay, now for uppercase A it is ranging from 2 to 4. Okay, now if I compare the ranges, okay, so if all the small case A's has to appear before the uppercase A, okay, so what I need to check is for the last occurrence of A, okay, is last occurrence, if that is smaller than my capital A first occurrence, 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 then I can count A as special. Okay, but in this case if I compare, the last occurrence is 5 and my capital A's first occurrence is 2. Okay, so this inequality is violating, so I cannot count this. Okay, so yeah, the idea is this only. So for every character, okay, with respect to their casing, okay, if you store their first and the last occurrence, okay, and for every uppercase character, okay, so if you store their first and last occurrence also, okay, then you can simply check like whether they are overlapping. Okay, if they are overlapping then you cannot count them as special character. If they are not, and also make sure like the last occurrence is smaller than the first occurrence, then yeah, you can then count them as special character. Okay, so if I take this example, so A, B, capital B, capital C, A and B. Okay, so if I go for small case A, so I have small case A here, okay, which is 1, 2, 3, 4, 5. Okay, so the last occurrence of A is happening at 4. Okay, and the first occurrence of capital A is happening at 0. Okay, so you can see the last occurrence is not less than the first occurrence of its uppercase version, right? So A is not special. Okay, now for B, so small case b is appearing at 1 and capital case B is appearing at 2. Okay, so the last occurrence of B, okay, oh yeah, the last occurrence is at 5. Okay, so the last occurrence is 5 and the first occurrence of the capital B is happening at 2. Okay, so this is also contradicting with this, so I will mark it non-special. Cool. Now for C. Okay, so for C I cannot find any small case C. Okay, so I do not have any count. Okay, I'll say null. Okay, that means I can automatically say, like, for C I cannot do anything, so this is also not a special character. Cool, so here answer will be 0. Cool, so this is the idea. So for every character with respect to casing, just store their first and the last occurrence. Okay, and just iterate over all the character. Okay, and now for each character check whether the small case version of that character, okay, its last occurrence is lesser than the capital case version of that character, smaller than the capital case version first occurrence. So yeah, the idea is simple. So what I will be doing is I'll be coding in Rust. Okay, and I guess it will make more sense to you guys once you see the code. Cool, so first thing first, let's store the number of characters we have. So word.len. Cool, now what I will do is I will declare a finder. Okay, so let mut finder. So I'll be storing pair of integer, which is like the first occurrence and the last occurrence, i32, and I will declare it something like this. Okay, so I'll be iterating over the word. Okay, and I'll basically storing the first and the last occurrence, so I can initialize the first occurrence to some big number. So I'll say 00009. Okay, let me zoom this, let me do this. Okay, and for the last occurrence I will store -1 because I'll be maxing out. Okay, so I'll say something max size. Okay, now see, as per the ASCII table, or I guess the Unicode table. Okay, so I will have at max of like my capital cases will be happening here. Okay, and they will be ranked to like capital, so capital Z will appear. So I'm talking about the ASCII table. I'm not sure whether this is ASCII table or Unicode table. Okay, but in the ASCII or Unicode table, okay, so the precedence is capital versions. Okay, then the smaller case versions appear. Okay, so this will last to C, small z. Okay, so the length of this is, I guess it is somewhere between in 2 digits, maybe 200 or maybe within 100, I guess. So what I can do is I can set max size to something like 101. Okay, cool. So yeah, I created an array, so I'm storing a very big value for first occurrences, and I'm storing a very small value for last occurrences. Okay, and I'm doing it for this much amount of space, 101. Cool. Then next thing will be I'll iterate. So I'll say for I in range 0 to n. Okay, so first I will take the index. I'll say bytes of I minus b of 0. Okay, I need to convert this word into bytes because in Rust you cannot iterate over string like you can do in normal languages, like in other languages. Yeah, bytes. So it will not be mutable, it will be immutable, so I'll simply say word as bytes. Okay, Cool. So with this I'll get the index. Now that's use size. Then I'll say finder of index of first occurrence. I need to import std comp. I'll be requiring max and min functions. Okay, cool. So for the first occurrence I'll only store the minimum index, so I'll say finder of id x 0 and I, and I'm storing i32. I will be use size here, so I'll be storing i32. And similarly I can copy this line, paste it here. For the last occurrence I'll be storing the maximum I. Cool. And yeah, these guys are pairs, okay, or like tuples. So instead of this kind of indexing I need to use the dot operation. Okay, I missed it. Cool. So with this, for every character I have stored their corresponding first occurrence and the last occurrence. Okay, then what I will do, what I will be doing is I will iterate over all A's, and for like I will iterate over all the alphabet, and for every alphabet I will check this condition. The last occurrence of small case version of that, is it smaller than the first occurrence of uppercase version of it? Okay, so in order to do that, what I will do is I'll say let mut small, so a, and I'll say let mut large equal to b of capital A. Okay, then I will initialize my answer and say i32 variable because I need to return it, and in the end I can return it. And yeah, so here I'll say while small is less than z, because I'm starting from a, z. Okay, I'll first find the small index. Basically I'm finding the index with respect to my ASCII table. Okay, so small index will be small minus the byte representation of 0, use size. Okay, similarly for the uppercase version, okay, large index. Okay, for large index I'll be subtracting this. Okay, so I'll get the index in the ASCII table. Okay, then I'll check in finder. Okay, so I'll say if finder of small index last occurrence. Okay, last occurrence, if let's say the character is not there, okay, like in this example we saw. Okay, so for C I cannot find any small occurrence. Okay, there is only capital occurrence. Okay, so in that version, so for C I'll be storing this guy, so 1 0 0 0 0 0 9 and -1. Okay, so I can simply check whether C is present or not by checking the last occurrence. If last occurrence is -1, then that means this version of this character does not is not there in the string. Okay, so finder of large index of 1. And similarly, if I only have small case version of an alphabet, no uppercase version of that alphabet, then also I don't need to consider, because that guy automatically becomes a non-special character. Cool. So if this is the case, then I will simply increment my alphabet by 1. Similarly for large index I will increment by 1, and I will continue. Okay, otherwise, okay, if I have both the first and the last occurrence of smaller case version and the uppercase version, I'll simply compare if small versions last occurrence is lesser than the large case version of that alphabet's first occurrence. Okay, so if this is the case, then I can count that alphabet as a special character. So ans plus equal to 1, and similarly I will be incrementing this. Cool. So we're almost good. So I started with A, I'll keep on incrementing till I reach Z, and yeah. Okay, small index plus 1. Oh yeah, it has to be small. Yep, small plus equal to 1. Similarly for large index I need to do large. Okay, So I'm incrementing the characters here. So yeah, cool, it passed. If I submit, and voila, it passed. Cool. Now if I look at the time complexity here, okay, so if I look at the time complexity, so I am generating a constant space here, 101 only. So I'm iterating over them for this prefill values. So this will be a big O of 101, which is constant. I can ignore it. Okay. Then I have this thing where I'm storing per character their first and the last occurrence. Okay. Uh, then it will be big O of number of characters I have. Then in this loop, I'm simply iterating over all the alphabets. Now I know the number of alphabets are 26. So this while loop happens 26 times. So this is big O of 26. Cool. And yeah, since my finder was an array, so getting these values are constant time. Cool. So my overall time complexity will be linear. Okay. And if I look at my space complexity, okay, so I'm just creating this finder and that to be of a constant size, which is 101. So I can say big O of 101, but since I know how much space I require, okay, so with respect to input, it will always be constant. So I can say big O of 1. So yep, so this is my time and space complexity. Cool. So this was the Rust version. Okay, now I can show you the C++ version. Okay, in C++ version, so the concepts are same. So I'm creating the finder and I'm creating a finder of size max size equal to 101. How I came up with 101? Because if you look at the Unicode table for or maybe for characters, in programming, does it show? Yeah, all these characters are happening inside a Unicode table inside every programming language. Okay, so every character has been given some index, or maybe it's a ASCII table. I'm not sure. Let's see. Yep, 1 to 32. Let me check a Google thing. Yep. Yeah, you can see. So for this character, I have 65 as the index in the ASCII table. Okay, so yeah, that was all ASCII values. So yeah, what I'm doing is for A, to represent uppercase A, okay, I'm storing 65 minus the byte version of Z, 0. Okay, so what it will do is, so it will take zero's index, which is 0, and it will subtract it with A, which is 65. Okay, so I'll get 65 as the index value for capital A, and similarly it will go till Z. Okay, so I'll be storing 65 to 90, okay, values, and for small case A it is 97, and similarly I'll be storing 97 till 122 for small case or for small alphabets. So yeah, so in total you can see like the maximum index I can violate is around 122, but somehow I'm not violating. Interesting. It's happening because I'm doing minus of 0. Interesting. So none of the test cases are having small z. Ha! Okay, so essentially this code should fail because for finder I'm storing 0 to 101. Okay, or basically 100. Okay, and I'm storing word of I minus 0. Okay, now 0 has the index of 0 in the ASCII table, but small z has the index of 122, and if I subtract them, okay, I'll be getting 122. Now this 122 I cannot fit in this table, so essentially I should get some error, but LeetCode is accepting. Let me test this with this test case. Let's say Z, capital Z. If I run this, phew, it worked somehow. Interesting. Is it allocating more space? Ah, okay, got it. Okay, so essentially these are numbers. Okay, so for number the index value is 0. Okay, but if you consider those number in character level, okay, now my 0 character has an index of 48. Okay, so essentially what I'm doing is I'm not subtracting 0. Okay, I'm subtracting 48 from this. Okay, now with that, my small z, okay, that is giving me not 122, okay, that is giving me 74. Now this 74 I can fit in a 100 size array. Cool. I also debugged it now. Cool. So yeah, so this was the idea. So I'm creating array size of 101. Okay, now for every character I'm storing the first and the last occurrence, then I'm iterating over all the characters, all the 26 characters. Then for them I'm just comparing the small case version of that. If the last occurrence of the small case version of that alphabet is smaller than, okay, strictly smaller than the first occurrence of the large case version of that alphabet, okay, if that's the case, then yeah, that character is special. Cool. So this is a C++ code. The time complexity is same what I wrote in Rust, and voila. Phew, time limit exceeded. What? Oh, because I'm printing. Let me run this. Cool, it got accepted. Okay, now finally I will show you the Golang code. So idea is pretty same. Okay, I'm storing the first and the last occurrences of every alphabet in my finder. Okay, and this part stores it. Okay, now in this part I'm just iterating over every alphabet, and for every alphabet I'm checking if the small case version's last occurrence is strictly smaller than the first occurrence of the uppercase version of that alphabet. Okay, if that's the case, then yeah, my character is special. Otherwise I'm simply continuing. So yeah, those characters are not special. Cool. If I submit, voila, it got accepted. Cool. So this was the time and space complexity, and yeah, this was the code to solve it. So yeah, cool. So if you like the video, if you understand the solution, and if you think you learned something new, okay, please do subscribe to the channel, and you can provide a like to the video, and you can comment if you have some doubt. I'll be happy to answer your comments. Cool. So till then, stay tuned to watch more videos. Thank you. Bye bye.